Hello, my name is Shane Colby. My lab took place on Wednesday, April 22nd at 12 o'clock. I will be demoing Lab 12, the nanoprocessor. This circuit is meant to combine the functions of the register bank and the arithmetic logic unit. This simple nanoprocessor is capable of carrying out 9 specific tasks, given a set of instructions programmed into a ROM. There are 12 inputs to this circuit. The first 4 switches represent a binary input to load into a register. The next 2 switches determine which register we are manipulating or using. The last 4 switches control a specific set of instructions the nanoprocessor uses. This push button loads the information after setting the switches, and this push button resets the circuit. There are 21 outputs, each representing a segment of the 7-segment display. I will demo this lab by going through each of these instructions, and you can see how I input a specific set of instructions using the last 4 switches. I've already set up the switch combinations above each instruction, and another thing, you can ignore these last 3 digits, the display. Those have nothing to do with the circuit. Okay, so the first instruction wants us to load 4 into register 3. So to do that, we follow the guide right there. So the first 6 switches, and we're loading in 4. Okay, there it is, right there. Once we press the button, it should load all of the information in. Right there. Okay. Now all we need to do is display register 3, and there we have it. That is 4. Okay. Next, it wants us to load in 2 into register 2. So let's flip that back up. 2 into register 2. Okay. I'm going to press the button, and that should load. Now we're going to display it, and there we have it. That's 2. The next instruction is to store 5 in register 1. Okay, so here we go. 1, and here is storing 5. Okay, those are all the switches, and now we're going to set that. Now to display it, there we have it. That is 5. Okay, now next it wants us to move the value in register 1, which is 5, to A. Now what A is the accumulator. It is another register that is used to subtract, add, or multiply to a number in registers 1, 2, or 3. And that's what the accumulator is used for. So we're going to move the value from register 1 to A. And to do that, we follow those instructions. 0, 0, 1, 1, register 1. The first 4 inputs do not matter anymore. I'm not using them. And now I'm going to load it. Okay. Now, just to make sure it's there, we can display it by doing 1, 0, 1, 0, and there it is. That's 5 in register A. Okay. Now it wants us to add A to register 2, or register 2 to A. And what's stored in register 2 is 2, and in register A is 5. So adding them together should get us 7. So to move it, or to add it, is 0, 1, 0, 1, and we're wanting register 2 this time. Okay, and pressing this button should load it all. Okay, now let's display A again, and there it is. That is 7. Okay. Next, it wants us to subtract value in R2 from A, which should take us back to 5 and register A. So 0, 1, 1, 0 from register 2, loading it. There we go. 1, 0, 1, 0, and there we go. Back down to 5. Okay, now we're going to multiply the contents in A and R3. It's going to store it in A once again. So R3, the value in R3 is 4. The value in A is 5. 4 times 5 is 20. So once we carry out this operation, it will display 20 in register A. So let's go ahead and do that. 0, 1, 1, 1, register 3 this time. Now we're going to load it and display it. 1, 0, 1, 0. And there it is. That is 20. This is the nanoprocessor for the final lab of the semester, Lab 12. Thank you for watching.